In this video, I am going to explain Parsevals relation or theorem property of the Fourier series. Parsevals relation or theorem property of Fourier series. Statement let Fourier series of x1 of t is equal to Cn. Fourier series of x2 of t is equal to C1 and C2n, C1n and C2n, both x1 of t and x2 of t are complex. Then the Parsevals relation states that 1 by t integral t naught plus t x1 of t x2 of conjugate of t dt is equal to sigma n is equal to minus infinity to plus infinity C1 n C2n. This is the Parsevals relation. The Parsevals and Parsevals identity. Parsevals identity states that 1 by t integral t naught plus t mod x of t whole square dt is equal to sigma n is equal to minus infinity to plus infinity mod c of n whole square. This is the problem statement, property or problem statement of the Fourier series. Parsevals relation or theorem property. X1 of t and x2 of t are two continuous time functions, periodic functions, with Fourier series are C11 and C1n and C2n. Both are x1 of t and x2 of t are complex in nature. Proof. Consider Parsevals relation. Parsevals relation, left hand side. Parsevals relation, left hand side. 1 by t, t naught plus t, x1 of t, x2 of conjugate of t, dt, LHS. That is equal to 1 by t, t naught plus t. Put x1 of t is equal to complex exponential of Fourier series form. Sigma n is equal to minus infinity to plus infinity Cn e power j n omega naught t. X1 is replaced with this one and x2 star of t into. Bring this sigma function outside. Sigma summation function sigma n is equal to minus infinity to plus infinity with Cn and 1 by t integral t naught plus t x2 conjugate of t e power j n omega naught t dt. That is equal to sigma n is equal to minus infinity to plus infinity Cn 1 by t integral t naught plus t x2 of t e power minus j n omega naught t dt minus term. Here e power j n omega naught is replaced with e power n omega naught t conjugate. Conjugate is applied, minus term is replaced with plus. Write down this in this form. Therefore, sigma n is equal to minus infinity to plus infinity 1 by n 1 by t t naught plus t x2 of t e power minus j n omega naught t dt conjugate is replaced with entire one is replaced with C2 of n or C1 of n C2 of C2 of n C2n conjugate. Therefore, sigma n is equal to minus infinity to plus infinity C1n. Here C1n because why? Because Fourier series of x1 of t is C1n. That is the reason we use C1n. Here C1n, 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 and C2n. The proof is completed. For Parsevals identity proof, for Parsevals identity proof, x1 of t is equal to x2 of t is equal to x of t. Therefore, for Parsevals identity proof, x1 of t is equal to x2 of t is equal to x of t 1 by t t naught plus t x1 of t is x of t x2 of t is also x conjugate of t is equal to sigma n is equal to minus infinity to plus infinity C1 of n C2 of n is equal to Cn C1 of n is equal to Cn C2 of n is also Cn conjugate and therefore 1 by t integral t naught plus t. Any function with conjugate function is the modulus of x of t whole square. Here dt is there. Dt is equal to sigma n is equal to minus infinity to plus infinity mod Cn. This Parsevals identity of the Fourier series is completed.